Many word problems in related rates involve setting up an equation that we know in the past, like in example 1, working with the volume of a cube, or sometimes it may involve setting up a right triangle. Here in example number 2, a hot air balloon rising straight up from a level field is tracked by a ranger. So here is the path of the hot air balloon. Here is your hot air balloon. So this hot air balloon is going up 500 feet on the field from the lift-off point. This is 500 feet. At the moment, the ranger's elevation angle is 45 degrees. When this angle is 45 degrees, the balloon is increasing at the rate of 0.25 radian per minute. So this is probably dy dt if I'm to consider the y as the height of the balloon. How fast is the balloon rising at that moment? This is d theta dt, the change of angle, radian per minute. And now how fast is the balloon rising? What is dy dt at that moment? Looking at these questions here, we got a right triangle. And this right triangle involves angle. Looking at the picture that we in front of us, we have y, which is the opposite side to this angle. We can also make use of the length that is not changing. In this case, since the adjacent side in this case is a constant, we don't need to worry about using this number or using this variable, because technically x is not a variable. So using the tangent ratio, tan theta equals opposite over adjacent, we can then differentiate both sides of the equation with respect to time. And as I differentiate tangent theta, it gives us secant squared theta. And knowing how we are differentiating this function with respect to time, I need chain root d theta dt. On the right hand side, once again, as x is a constant, I can take out a constant and differentiate this with respect to time, which will simply give us dy dt. This is what we are trying to find. Here is the unknown. We're trying to isolate this. For now, we got the angle. The angle is 45 degrees, or pi over 4 in radian. D theta dt, the change of angle with respect to time, it is 0.25. Substitute it into the equation. And for the x, at this point, when the ranger is standing somewhere that has an elevation angle of 45 degrees, you can then calculate this adjacent side using tangent 45 equals opposite over adjacent. And by solving for x, you will actually end up with 500 for the adjacent side. So as you plug in 500 in this case, you can then solve for dy dt, which is the increasing rate, the change of its height, the balloon's height with respect to time.